Start button.
Hi, everyone. Welcome to the water webinar. Today, we're lucky to have Luke Milliron presenting, asking growers if their trees are thirsty. Luke is an orchard systems farm advisor for Butte, Glenn, and Tehama counties. Thank you so much for being here, Luke. Take it away.
All right. Thank you, Ellen and Safiq, for the invitation. Yes, my name's Luke Milliron, and I'm a farm advisor up north in Butte, Glenn, and Tehama counties. God's country, just beautiful, beautiful part of the Central Valley. And in this role, which I've been in for almost 5 years now, I'm serving all commercial orchard systems, doing research primarily on almonds, walnuts, and prunes, as well as olives and pistachios a little bit. So here's a breakdown of the acreage I serve. It's kind of equal parts almond and walnut, and then a much smaller percent is prune, and then only 1% bearing acreage is pistachio, but it's definitely increasing, and a lot of stuff just isn't reported yet. And it's been it's a lot of acreage, 255,000 up 11,000 since 2018. So I'm excited that we were just talking about all of the release of positions for farm advisors, and then the specialist release will be soon, and we're going to get more farm advisors up in this region soon to help me out. So that I'm super excited for that. So as a farm advisor, you may know that farm advisors are generalists. We have to get called out by growers anytime something's going on, but oftentimes it comes back to water in one way or another. So here we have Phytophthora in the upper left in walnut, and then we have a bacterial spot on the upper right in almonds, which is water splashed. We have in the lower left a flooded walnut orchard when we had that incredibly wet spring of 2017, and we had emergency diversion from Lake Oroville, and then the rivers went over, and there were some orchards that were sitting in water for months. And then we have whole rot in almonds on the bottom right, and that's a problem that you can get into towards the end of the season if you are running a little too wet or a little too high in nitrogen. So getting called out, and the grower says they're calling you for X, but it often ultimately comes back to some water or a cultural management related to water in some ways. So my research program has 5 pillars that I'm trying to work towards. And the first one is I just don't want trees to be maimed or killed. How can we keep orchards living longer and being more profitable? So looking at new rootstocks, cultural controls like keeping water off the trunks when you have sprinkler irrigation. And then the second pillar is evaluating new varieties in almond and walnut and prune. And then promoting disease management of some of our annual diseases is the third. And then whole orchard recycling, really specifically for walnut, has been a big focus of mine. There's been a lot of success in almonds, and now I've been doing work in walnuts. So that's also something where I'm hoping there will be a water component. Brent Holtz and others have shown that with whole orchard recycling, you can have greater water use efficiency in your orchard. And then the 5th pillar that we'll really be talking about today is plant-based irrigation management. And the main example, and the specific example we'll be focusing on, is the pressure chamber. So what is the pressure chamber? Here we are just going to go through the soil plant atmosphere continuum that you are all very well familiar with, of going from more and more negative as water travels from the soil to the root, through the xylem and out through the leaf. And so the pressure chamber is great because it allows us to tap into part of that soil plant atmosphere continuum and directly measure what's going on with the tree. And these measurements at midday are commonly used for several orchard crops for irrigation management, essentially choosing when to irrigate. You can see the reading on the gauge here in the bottom right. And when that reaches a threshold, you initiate an irrigation. If you check it and you haven't reached that threshold, you can wait and actually save on some water. So here's the concept in a kind of a bike pump style pressure chamber unit here. So you have a bagged leaf for at least 10 minutes, and then you remove that leaf from the tree, and you place it inside the pressure chamber. And then in this case, you get your workout in and you pump it up. And then when water is visible on this cut surface, you take the reading. And of course, as we showed in that soil plant atmosphere continuum cartoon, trees, of course, and all plants are under a negative tension is how we express it. And so what we've done is we've put back positive pressure just in excess of what the negative tension is that the tree was under, and that's when water flows out. You can see it with the magnifying glass. And here is what that process looks like: the bagged leaf, placing it in the chamber, and then waiting for water to bubble out. Growers often balk at the expense here. So it's $1,500 for that bike pump style that is, it's, with it being such a manual approach, it's only good for the lower tensions. And so it's pretty darn good for walnut, and maybe the very start of the season in almonds, and kind of nothing else. So really you need to be spending $2,500 or more for one of these kind of console units. But what I'm often telling people is, this is like any piece of equipment. You buy tractors, you buy all sorts of things, and it amortizes over the not only however much acreage you have, but these things last a long time. I'm using pressure chambers from farm advisors long retired. So it's really just the price of labor at the end of the day. So the simple interpretation, again, is just to look at the gauge. And so we have some ranges that Alan Fulton and Ken Shackle at UC Davis and others developed. So for an example would be 14 to 18 bars. In almonds would be moderate stress. It's something, a moderate stress, a regulated deficit irrigation that many growers impose right around the whole split timing, about a month before harvest. And that helps control that whole rot disease we showed the photo of, and it can make for a more uniform and faster harvest. But then you don't want to get more stress than that. You could be getting into trouble. But the more advanced interpretation is to be looking at a baseline and talking about bars below a fully watered baseline. So the reason we need a more advanced interpretation is that on a tree that has all the water it needs on a super hot, windy day, it is going to just read more negative with the pressure chamber than it would on a cool day. And yet that doesn't necessarily mean it needs to be irrigated. It doesn't. It has all the water it needs. And so that's why we've developed these tables for all the different crops by just having really well-watered trees. We would say probably excessively watered. This is not how you'd want to actually manage your orchard, but experimentally really well-watered trees, and have them under all sorts of variable weather. And that allows us to build an equation and graph this simplified chart here. So example would be if it's 95% or 95 degrees outside and 20% relative humidity, and your trees are at 7.7. So this is in walnut. We have 95 degrees and then over to 20, so 5.7. So your trees are 2 bars above the baseline. So you don't really need to irrigate at all. The fully watered, oh no, it's the other way around. So your trees are 7.7. The fully watered baseline, a fully watered tree is 5.7. So it's your trees are 2 bars drier than the fully watered baseline, and it would be a pretty good time to irrigate. We typically recommend irrigating when trees are 2 to 3 bars drier than the fully watered baseline in walnut. So, and then it's 2 to 4 bars in almonds. And of course, the other best practices, follow in irrigation management. You don't want any ponding. That's going to lead to increased risk of phytophthora. You want to check your distribution uniformity before you start the season. And then what we found, especially in walnut, is that the beginning and the end of the season have really important implications. So I should have done it even earlier, but I must declare my bias here that I am not just being an objective researcher and extension agent, but I am just heavily biased in favor of the pressure chamber. And so here I am, 21 years of age, with the pressure chamber. So I've been taking pressure chamber readings for as long as I've been allowed to legally drink. So I am a big fan. And so this is me as an undergrad studying at Chico State, and my research as an undergrad there led me to Ken Shackle's doorstep at UC Davis, and led me to do a master's with him during the midst of our previous round of drought in 2014, 2015, where we were asking the question of if instead of pressure bombing a leaf or a shoot during the regular growing season, whether we could actually pressure bomb a dormant twig, which we showed you could do. And so the question I have, and now as a farm advisor is, we have all this research behind the pressure chamber. Do growers actually use it? And so the Almond Board of California, of really all the crops, has been the most hard driving in terms of assessing what their growers' practices are and trying to improve their growers' practices and try to increase the adoption of more and more advanced best practices. And so they call that their improvement continuum. So for plant water status at the most basic 1.0 level, you're just looking at the tree and assessing whether the tree needs water. And then the intermediate level is you have a pressure chamber and you may not use it very often, but periodically you would come in and check what your trees are looking like. And then the most advanced is where I'm trying to get growers to, which is using it to initiate regular irrigations. You have that advanced interpretation where you're comparing the readings to the fully watered baseline, and you're using it to start the season, to do that regulated deficit irrigation around whole split. And the adoption rates that the Almond Board found was that basically everyone looks at the tree. That's unsurprising. And that a little under a third are using the pressure chamber, and 27% are using it at the most advanced level. And yet this is probably wildly an overestimate. And they should be coming out with new data soon. But when the Almond Board went out and asked growers, they did it at small field meetings. And I think the Almond Board field meetings and in-person meetings are the same bias that all of our UC grower meetings have, in that they attract really you're preaching to the choir. You're preaching to the best growers oftentimes. And so the adoption rates are kind of absurdly high. And yet the Almond Board has been able to get much higher adoption rates. Some of the larger almond processors like Blue Diamond have financially incentivized growers filling out this information on what practices they're doing or not doing. And so a new round of information is coming out soon, and the numbers are going to be coming down considerably, I'm told, which is going to be more representative of the actual industry. So what is my sales pitch to growers? In trying to increase adoption of this, I'm talking about that knowing the water status of the tree has just tremendous implications for how fast your trees are growing, what is your yield, and it has really important tree life and death health consequences. So all of that impacts your bottom line. And I've been told from some of my largest growers that they can use the pressure chamber for $10 to $20 per acre cost annually, versus some of my smallest growers that can't afford to pay someone to take pressure chamber readings alone, or they're small but not small enough that they would be out there taking their own pressure chamber readings. It's nice that some of the consulting firms that also are doing the consulting on their pest control for the farmer now offer, to hire college students and have them out there taking pressure chamber readings. And so I've been told that's costs about $40 per acre for that service per year. And it has tremendous, tremendous implications. This is some work from Bruce Lampinen, extrapolating from some field research he did. And after 8 years of growth, the trees that were kept at 8 bars, so much less stress than 16 bars with twice the stress, they had reached 80% light interception. So how much light is hitting the ground at midday when you're looking down an orchard row is only 20%. So 80% of that is shade. It means the trees are intercepting light and they're converting that into yield. And the trees that were at 16 were at 48%. They were under half of the light being intercepted, and then 12 was in between. And just on 4 bars of stress after 8 years, if you had 80 acres, that would be $400,000 in lost revenue. So really important implications early on for growth and early yield. And then in walnuts, especially, it just seems to be a very tricky crop to irrigate, where it's this Goldilocks crop where they've shown that they're really, it's tough or impossible to do successful regulated deficit irrigation in walnuts. And yet it's very sensitive to over irrigation. And so Bruce Lampinen and others had some trees at UC Davis and intentionally overwatered them. And they were able to find all of these symptoms that farm advisors had been reporting seeing in the middle of summer all across the Central Valley for years, and found these only in the overwatered trees. And so there's just more and more research from farm advisors and extension folks and professors on campus showing just incredible long-term root and tree health impacts from over irrigation in walnut. And of course, we know that over irrigation can also interface with the disease triangle by influencing how much oxygen's in the root zone, and really getting you into trouble with completing the disease triangle and allowing something like Phytophthora to take hold. But it's not always disease. This is orchard following a wet spring where these walnut trees, many trees are in decline, and yet there's no clear cankers that would be evidence of something like Phytophthora, and yet the roots look really unhealthy cutting into them. So we just think that this is just simply having a saturated root zone, especially early in the season. And so this led Ken Shackle, Alan Fulton, Carrie Arnold, and others to research this question in walnut. And so they did different treatments, waiting 1 bar below the fully watered baseline, or 2 or 3 or 4. And so, of course, this initiated that initial irrigation across a long period from May all the way into June. And of course, the 4-bar trees are the most stressed when they are first irrigated, because they have finally reached their 4 bars below baseline. And yet, when it came to the end of the season, growers had the thinking that we can't run, we got to start early and we got to irrigate, hard all the way throughout. Else, at the end of the season, the trees will look like crap. They'll be water stressed. And what they found was the opposite. The trees, especially in say the 2 or 3 bar treatment, they looked much healthier than the trees that were irrigated when the trees were still basically at the fully watered baseline. And those trees not only looked worse, they were more water stressed. So potentially overwatering in walnut early in the season can damage the roots potentially and lead to higher water stress at the end of the year. And after many, many years, not only have the implications for delaying led to some very minor pros and cons for yield and quality, it's largely been unaffected. And yet, compared to ET minus rain, the delay trees that are looking great and yielding well are basically using half the water of what irrigating purely by ET would say to do. So really important and startling findings in walnut from that work. So how have I delivered this sales pitch, and how have my colleagues, Alan Fulton and others, been delivering this sales pitch, and Kurt Pierce on this call? It's often in one-on-one farm calls and phone calls and texts, and that relationship with growers, as well as in direct grower contact at meetings and presentations. And then even pressure chamber field days is a great way to do that. We also have quarterly Sacramento Valley almond, walnut, and prune newsletters, where we're often advocating pressure chamber use. We have regional websites in the Central Valley. Phoebe Gordon and I, of course, have a podcast where I'm always plugging the pressure chamber. We often write trade magazine articles, or we're interviewed by ag media folks. And then, of course, social media, especially LinkedIn, seems to be more and more where I find the most clientele interaction. And then, have there really been any sales from all this pitching of the pressure chamber? So again, this number is from CAST, the California Almond Sustainability Program, where they go out and do these surveys. And these numbers are wrong. They are just a flat out highly, highly inflated. And I'm looking forward to getting some more realistic numbers soon. But I think what is interesting here is the difference between the Sacramento Valley versus the state at large. And so for using the pressure chamber regularly, the Sacramento Valley was 48%, had higher adoption by 48%. And then initiating irrigation, 37% higher than the state average for that. And so even though these absolute numbers aren't correct, I think when the new data comes out, this trend will hold, that the adoption in the Sacramento Valley is much higher than in the central San Joaquin, or the northern San Joaquin Valley, or the southern San Joaquin Valley. And I think that's because of a couple things. I think it's because of the hard driving extension work of folks like Alan Fulton that have been driving this message of pressure chamber usefulness for so many years. But I also think that the pressure chamber does have more usefulness in the Sacramento Valley because we get more rain. And if you're in a part of the San Joaquin Valley, especially southern San Joaquin, where you get minimal rainfall, I think something like ET is a lot more useful, because you don't have the contribution of rainfall really confusing what the roots potentially have access to in their root zone, or even deeper than what we thought. Because that work in walnut, and part of why those trees are successfully using, what looks like 50% of ET, is that they're potentially using water in walnuts down to 10 feet in some orchards. So trying to get that all calculated out in ET, which is always going to be a kind of back of the hand, napkin calculation for someone's orchard, is tough to do, but is much more straightforward if rainfall's not a significant part of the water picture. And then I've also had just this winter in some winter meetings, in-person meetings, talking about the pressure chamber, in this case to prune growers and walnut growers in Red Bluff, as well as prune growers in Yuba City. So the northern Sacramento Valley versus the southern Sacramento Valley. When I asked folks in the northern Sacramento Valley and Red Bluff if they use the pressure chamber, I got over half, about half or over half of the hands to go up, versus it was closer to a third of the hands in the southern Sacramento Valley in Yuba City. And I think a lot of that is the contribution of Alan Fulton and talking about the pressure chamber to growers. And I think that more and more gains are still possible. So one of the big growers in Butte County, after years and years of exposure, I mean, he's heard Alan's talks, he's heard myself talk, he's heard others talk about the pressure chamber. He gets our newsletters. He's very plugged in with Extension. He was even volunteered to be on the committee that hired me for my position. But finally, in 2020, he adopted the pressure chamber across his 2,000 acres and reported that the trees are looking better and that he's saving on electricity, and that just intuitively, based on irrigating, looking at ET and kind of irrigating based on your gut or when your neighbors are irrigating, which is a common way to irrigate, unfortunately. He said without the chamber, he would have been over irrigating during those heat spells and potentially getting the trees into some more stress. And this is just a photo from last week that Kurt Pierce took. So Kurt Pierce, Franz Niederholzer, and myself did a training for the largest almond grower in the Sacramento Valley. And they have 12,000 acres of almonds, and only took pressure chamber readings about 4 times last year on some of their acreage, but they're looking to dramatically expand that work. And so I think that moving along this continuum of advanced irrigation management is possible. But obviously, I'm not going to get them all. Kurt is not going to be able to convince them all. Not everyone is going to adopt the pressure chamber. And so what I start with is that, ET is a gateway drug for irrigation management. So I don't want growers to irrigate when it's just been super hot outside, and so they think the trees, it's probably a good time to start the irrigation season, or simply irrigating when their neighbors irrigate, or simply irrigating for the same duration every single week, all season long, based on when it's the cheapest in terms of the PG&E hours. So there are definitely folks who kind of set it and forget it with their irrigation management, but at least looking at ET and adjusting based on the weather is, I think, an important first step to take. And then once you're doing that kind of work, it's easy to get hooked and get into the more hardcore drugs of irrigation management, like soil moisture. And if you're not going to do the pressure chamber, there is now automated stem water potential readings The best correlation has been found in Ken Shackle's work. He's looked at the pressure chamber versus Ceturus, and he's looked at it versus Fluoropulse and some other technologies. And so far, the best relationship he's found is with Fluoropulse. And so here we have these sensors attached to an Ammons trunk, and he's found very good agreement. But is it a representative tree? So the first time I was able to use this technology, I didn't think about assigning the tree very carefully. And I assigned it to like the worst tree in the orchard, the tree that is consistently the wettest tree. So even though the relative readings were still valuable, it was still trending down when there an irrigation needed to occur. The absolute value was not very representative of the rest of the block. But you could find a good tree if you have a pressure chamber. You could find a representative tree to attach this expensive technology to. And then that efficacy, that cost efficacy is also unknown. I think these are about $1,000 per station right now. And are you going to use that to irrigate 40 acres or 80 acres, or do you feel like you need more than one sensor because there's so much variability? So unknown cost efficacy, but potentially comparable to some pressure chamber readings, especially as the cost of labor goes up. And it's not currently available for walnut. When you injure a walnut tree and you insert anything, a walnut tree will bleed, which leads to pressure readings of 0 or positive. So that is not useful. So Ken Shackle is gonna figure that out, but for now, it's still just the pressure chamber in walnuts. But it's really nice. They give you a graph that you can get on your phone or your tablet or your PC, and you can also include when you did pressure chamber readings. Those are the few stars you see here, and it reports it in bars below baseline, which is what we have all of our thresholds based on. So my pitch to growers is to at least get into ET, which is made possible by Kurt Pierce sending out a weekly email where growers can see what is the ET for their crop that they grow in the area they grow it. They get an email every week with that information during the irrigation season. So that's absolutely key in getting people to start down this continuum. And then the pressure chamber for starting the season, hopefully as a weekly trigger. And then if you're going to do any deficit. And then if you're not going to use the pressure chamber, again, you can employ a service to do it. If you're just kind of not the right farm size where it makes sense for you or someone else to do them, you can have your pest control advisor do them for you. You could invest in automated stem water potential, but at least use something direct in the field. So even though soil moisture isn't looking at the tree, it's not measuring what we care about most. Soil moisture is still really valuable. It's still a direct measure in the field. And it is also, telling you things like how deep is your irrigation going based on your set length. So it's an important technology that you should have anyway. So. And then some next steps in where I'm hoping to go is of course to get the new batch of data from the California Ammon sustainability folks, and use that kind of as a baseline for the rest of my career to see if those now more representative, larger sample, whether we can bring those adoption rates higher. And then I'm also doing a survey with Kurt Pierce and Clarissa Reyes and Ken Shackle and other folks, surveying almond and walnut growers about their winter and early season irrigation practices. And then hoping to also validate in the field when growers are initiating their regular irrigation for the year. What is the pressure chamber reading? If they don't have the pressure chamber, what are their trees reading? Are they kind of irrigating based on ET or history or some other way, but it just happens to work out and kind of agree with the pressure chamber? Or are they potentially irrigating on the early side? Is something we want to find out. And then we're going to have a pressure chamber training at the Chico State Farm on March 31st. And then folks like Kurt and myself and the Ammon board are willing to even loan those pump up pressure chamber units out to growers if they say, whoa, that looks like a steep investment. I'm not sure whether I want to do it. We can say, well, you can give it a shot for a season. I'll work with you. I'll train you up on it. I'll give you the equipment and you can see whether it's something worth purchasing. So those are some of my ideas of how to proceed, but I'm really interested in anything that this group has for ideas for grower adoption, not only for the pressure chamber, but for anything that you all have been researching and trying to get out to growers. How are you seeing as the best way to extend that information or to get adoption? I would be eager to hear. So that is everything from me. It's just tremendous thanks to all of the commodities that support my work. Thanks,
Awesome.
folks.
Thanks so much, Luke. Yeah, if folks want to type in questions or comments into the chat or jump in, maybe I can kick us off. I have a number of questions, but I also know that I come from a place of ignorance. I guess could you elaborate a little more, Luke, on what some of the barriers to adoption of the pressure chamber are? Because it sounds like the technology has been around for a while. You've been, trying to extend information about it. Alan Fulton, the information's been out there, and is it prohibitively expensive? Is it really hard to use? Or are there other reasons that explain why everyone's not using it? I'm convinced.
Yeah. So this is we don't fully know the answer to this question, and my colleague, my podcast co-host Phoebe Gordon and I like to argue about this. Is that adoption rates are really low in the central San Joaquin Valley where she is, and she's like, growers just are never going to do this. And I'm seeing growers still coming up to me at field meetings or at any meeting saying, hey, I'm looking to get into the pressure chamber. So there still seems to be folks who are able to be convinced to get into it, at least in the Sacramento Valley. But I would say that it not only is it that initial cost of the unit is often mentioned as a barrier, but it's just I love doing it. I just find it so fascinating to directly measure the tree and have it tell me whether it is thirsty or not at all thirsty, because sometimes it is not at all what you would guess walking out there on a hot, dry day and the tree says, you do not need to irrigate yet. You can wait a few more days. It's really awesome to find out, and yet it is very laborious measurement to do, and yet it's a skilled measurement. So it's tricky. Both, you're doing readings at full day in the sun, in the heat, maybe in the smoke, in the summers we've been having. And it's tough labor-wise because it's tough to assign someone as just a pressure chamber person because it's something that can only be done at midday, about 12 to 4 p.m. So from a labor assigning kind of perspective, that's challenging too. So those are some of the barriers, but it seems that there's a lot more folks willing to do it. So it'll be interesting to listen, get these surveys back and have more conversations with growers about what the barriers are.
Yeah, cool. So you started alluding to this other question I had was in the absence of the pressure chamber, are farmers more often overwatering or underwatering or some of both? And it sounds like I was curious if there are studies that looked at, the effect of adoption of the pressure chamber on water use and yields, in a sort of, experimental basis,
Yeah. And I don't think that there is much. And that's why we have this survey going out and hoping to do some field validation of seeing when growers if growers over irrigate or if they don't. I have been surprised. I definitely went into this job just because I'm often called out on farm calls where over irrigation seems to be what caused the problem. That I often have the starting hunch that growers over irrigate. And yet when I've actually been able to like validate that in the field by setting up a trial, they don't over irrigate at all. Like my intuition was totally wrong in those couple cases. So I'm really fascinated to get a much larger sample size and see where there's room for improvement, or if a lot of growers use soil moisture, and sometimes soil moisture is in good agreement with the pressure chamber, so they may not be far off from what soil moisture would be saying.
Mhm. Interesting. Well, since I'm not seeing anything in the chat now, I mean, I have another question. I don't want to hog all of the time, but I guess maybe one more for now. I mean, I think it's interesting that you're talking about this technology as being around for it, like it's been around for a while. And so I'm curious, like how you would describe sort of like the cutting edge of irrigation technology in terms of, how much to irrigate and like how that technology has changed over time. And is it the pressure chamber, or is there reason, or is there new stuff that for some reason the pressure chamber still dominates as like the cutting edge technology to be using?
Yeah, that is interesting. I think that there's just this explosion of new technologies, especially in recent years now with drones and remote sensing, and just I mean when I listen in on water PT webinars from our colleagues talking about the latest technology, it often just goes right over my head. I mean, it's just incredible, and unfortunately I think oftentimes it still goes way over growers' heads too. So um, and an example is I talked at a field meeting in the Southern Sac Valley a few months ago, and I spoke about just very basic irrigation management best practices, and then Malika Noko talked about some drone stuff and more advanced stuff. And she asked growers, show of hands, how many of you have used a drone? And like no one raised their hands. So I think that there's a lot of technology out there and in development, but how much adoption of it is unclear. I think that Kurt Pierce and I were just talking about, one of the best advancements that we believe in recent years has been just mapping out the land in advance with soil surveys, or even more uh, fine-tune things like Veris soil mapping, where you can break up the orchard into multiple zones and irrigate by soil type, and that can just lead to much higher efficiency, because you can, if you have a poor distribution uniformity, or if you're just have a spot that's going to always be wet and always be dry, no amount of technology kind of after the fact with sensing and other things is going to help you. So that's another technology I'm really excited about, but it still seems to be the pressure chamber, and then this fluoropulse technology is very new. So there's no data on grower adoption of that yet. So it'll be interesting to see whether folks invest in the automated technology.
Luke, I'm just curious, how many readings do you have to take in order to get a representative number that you can use for irrigation?
Yeah, that's a great question. The typical way we think of it is like, we don't know how much variability is out in your orchard when you first start. So we recommend starting with more readings, 10, 12 readings in an orchard, and then getting that down to maybe just a couple of trees that are consistently kind of in the middle of the pack. And you could use those as your go-to trees to check for that orchard. And that may not seem like doing a very thorough scientific water stress assessment of the orchard, but when we have soil moisture, or we have fluoropulse, we have any of these expensive sensor technologies, we're often relying on a single spot in the field also. So I think it's a technology worth doing, even if you're only doing, a couple trees per orchard.
And the second part, I think this is something that you mentioned earlier. Do you see, a role of drone in terms of cutting down some of the labor thing that you were discussing? So maybe if you build a, let's say, a transfer function between pressure chamber and drone, some indicator or metrics, and that would allow you to cover much larger area in, really short amount of time.
Yeah. Yeah, that's going to be really interesting to see, and we should see that some of that early data soon. Is that we have a start of irrigation trial in Ammons at the Chico State Farm, and Malika Noko is doing drone flights, and then Troy Magny has a tower with all sorts of crazy sensor technology. So between all of their sensing, which is also trying to look at plant water status in a more remote way, can we eventually not need the pressure chamber and actually have a much more whole field look at water status instead of individual trees manually done. That would be great, but that kind of thing is not currently in growers' hands.
Yeah, I'm just curious because I think, the lawn just next to our building, we were complaining that there's, the sprinkler basically turns on in the middle of the day. And we were complaining, then said, oh, because that's when that labor is available, right? Or that's when,
Yes.
So oftentimes,
Yes.
it doesn't matter what technology you got and how much science you got, they're going to irrigate based on when the labor is available and when the electricity is cheap, right?
Exactly. Yep. So that's always going to be, that's always going to be a limitation to adoption of new technologies. And my advice to folks working on the advanced technologies is always like, if you're going to hand this to growers, it's got to be bulletproof. Like you got to be able to run it over with a tractor, and it's got to be intuitive and actually help them make decisions. Because a lot of this stuff is just really, it's over my head. So I think it's over my growers' heads too.
Yeah, Anshika, go ahead.
Yeah, hi. Thank you for your talk. I'm a PhD student at UC Merced working with Dr. Shafiq Khan and Dr. Martha Conklin. So basically, I'm trying to model crop growth and water use using a crop-based model, CropSyst. And while doing almond, we had a few questions, and this may not be what you just talked about, but somehow related. And yeah, I have been listening to your podcast by you and Dr. Phoebe, and it has been helping me a lot.
Oh, good.
Thank you for that. So during the harvest seasons, is there a lot of leaf fall due using the mechanical machines that you use for harvest? Because when I'm doing the modeling of ET, and we were thinking if there is a lot of leaf fall, should we consider that as part of modeling or not? So
yeah, I would say that depends on the irrigation system. There are folks with double line drip irrigation, and they're able to manage their harvest in a way that, you can't get the nuts wet once you've shaken them. So like they do fancy sweeping patterns and they get the nuts away from the irrigation, and yet they're enabled in that way to continue to irrigate. And so the trees don't get super stressed, and you don't have a lot of defoliation. But I know for the orchard where I do this start of irrigation study, as well as where we have a variety trial of 30 different almond varieties, it's solid set irrigation, which is the main irrigation in the northern Sacramento Valley because of frost. And with that, you don't have the ability to irrigate from the moment you shake the trees and nuts are on the ground to like the 7 to 10 days while they dry, and you have to pick them up. And so the trees get into just really crazy high levels of stress. And so you have defoliation both from direct water stress as well as from the spider mites that are exacerbated by water stress. So In some of those orchards where you don't have drip irrigation, you can get into tremendous stress and some defoliation at harvest.
Okay, yeah, thank you. I think that was also related because one of the study showed that the ET after harvest went down and then again it went up. So I'm assuming that before it gets into dormancy, there's again few events of irrigation that happens. Okay.
Yeah,
And
both from water stress, mites, and I would say ET would maybe even go down because harvest is so dusty, and so you have the leaves are brown afterwards instead of green. So yeah.
That's interesting. Just last question. So how the irrigation is scheduled, does that also help or, aid in some way the dormancy period, when the dormancy should start for almonds or pistachios?
Yeah, I think that that's something we still don't know a lot about um, is the end of season irrigation management. And I think that more and more we're finding with the work of Maciej Winiecki at UC Davis doing all the carbohydrate analysis is that we want to keep the leaves on the trees as long as possible, photosynthesizing, storing carbon. Starting with it is as high as many sugars in that tree as we can possibly get before things totally shut down. So irrigation and avoiding extreme water stress is certainly part of that. But in terms of fine tuning recommendations, I don't think we really have that yet.
Okay, Wendy.
Thank you. Thank you so much.
Hi, thanks. My name is Wendy Resch. I'm with the Natural Resources Conservation Service, and we definitely have a bias towards soil moisture monitoring when we're working with growers to do irrigation water management practices. That I was really interested to hear that walnut trees were really sensitive to soil moisture. So one of my questions is, well, when we're setting up an irrigation water management practice with the grower, we're trying to keep them in between. We're kind of trying to keep them inside of a certain range of soil moisture, right? Like we don't need them to be all the way up towards field capacity, but we don't want them to drop too low, so we kind of set a range of soil moisture that we're looking at, and we're triangulating that information with ET as well, and we could be triangulating with plant moisture status too. But I was wondering, in your research looking at walnut and disease especially, is there a soil moisture content that we should basically try to avoid? I mean, is that something that we could sort of work into our irrigation water management strategy with a grower to try to help them avoid some of those disease issues?
Yeah, and I don't have that number in Cinnabars or something for you. I'm just not as experienced with soil moisture, and maybe Kurt can chime in if he has any idea. But the main thing that I've seen as really problematic in the interpretation of soil moisture sensors with walnut growers, especially smaller scale folks. One of my first farm calls when I started was, just kind of folks with walnut trees in their backyard south of Chico, and they had really nice fancy soil moisture sensing, and he's showing me the iPad and saying, I need to irrigate. Look, my bottom sensor is getting drier and drier. And so I need to bring that one back up. And what we have found with all of this start of irrigation research in walnuts is that the trees, you should let them use that deeper soil moisture kind of before initiating irrigation and early in the season, and don't try and refill it. You're really just farming the top foot or two the rest of the season, and that's perfectly fine. If you're looking at those bottom sensors 3-4 feet down, especially if you're looking at a 4-foot or 5-foot sensor and you're trying to bring that line back upwards, that means you're probably saturating the top 2 feet to get that that bottom sensor to respond. And when you're saturating the top 2 feet, that's where 80% of the roots are. So that is why in this case, his trees looked really bad. Was that he was overwatering to try to bring up that bottom sensor.
Thanks. That's helpful. Yeah, usually we're looking at those lower sensors to get a sense for is there a lot of leaching potential going on?
Yeah,
but
it is
right,
definitely
yeah,
useful for that. Yeah.
Yeah, most of the root action is happening in that top, 2 feet.
Mm-hmm. Yeah.
Okay, any last minute question? If not, then just join me saying thanks to Luke for taking the time and talking with us. So virtual clap.
Thanks, folks. It was a pleasure. Thanks for asking me, Ellen and Safika. Really appreciate it.
All right.
Thanks so much, Luke.
Enjoy your rest of the Friday.
All righty. You too.